Hi guys, and welcome back to lecture 13 of Python programming with me, Mace. So in lecture 12 we went over classes, and we kind of finished that little chapter. And even though we didn't go too deep into it, we looked at a few things that we're going to be looking at in this chapter. So you may remember back in our classes, we when we printed, for example, the components of a class, we used a dictionary. And if you don't remember, that's fine. But a dictionary is an example of a data structure, and that's what we're going over today. And that's what this chapter is going to be about, data structures. So in this particular lecture, we're going to be looking at one particular data structure, and that's going to be lists. So lists are probably the most commonly used in Python, and they have some quite unique properties that other languages don't. And we'll look into it a bit deeper. But for now, let's get right into it. So let me just delete this. Oh, whoops. Okay, so imagine we have a baker, and this baker wants to save all his breads. We would go bread 1 equals white. Bread 2 equals wholemeal. Bread 3 equals Turkish. And he has one more type of bread. Bread 4 equals rotten. So this baker wants to store all of his breads, and he wants to be able to access one of them. So what does he do? Well, pretend a customer orders, and he needs to access this one of these breads. So if they order bread 4, he would have to go print bread 4. And if we run this, we'll print rotten. But there's got to be a better way for doing that. Like, come on, what if you've got hundreds of breads, or another example, hundreds of something? Then this just doesn't work. And that's where data structures come in. So you might have seen it before, but data structures are Bob's breads. So Bob is our breaker, and we would create an empty list with square brackets. And we can actually put all the breads in here. White, wholemeal, rotten, and there was one other which I completely forgot. I'll just go Turkish. Yes, it was Turkish. Turkish. And now he has this really neat, really good list. Now, that's all in good, but if he's got a list, he's got to be able to use that list. So how does he actually use it? Because now if we try and do this, it's going to raise an error because, well, bread 4 isn't defined. We could just do print Bob's breads. And that would print this. But we don't want to do that, because this prints the entire list. And if a customer orders white bread, they don't want to get white bread, wholemeal, rotten, and Turkish. So what we need to do is be able to access one of these. So to access, we use something called indexing. And indexing is not that complex. It looks quite complex, but it's not that complex. So let me just get my pen. Okay, so let's say that we have this Bob's breads, right? To actually index it, we need to use some interesting syntax here. So right now we're just printing Bob's breads, and that's perfectly fine. It works, doesn't raise a syntax error, but it doesn't actually do what we want it to do. So what we actually want to do is go print. So we still want to print. Well, I'll make that lowercase. And we'll do Bob's breads. That's all good. And then we put square brackets in. Now, that is indexing. So Python already recognizes that you're only trying to get one element, and that's what you're trying to get. Now I'm going to put a random number in here. I'm going to put 3 in. Now, you may be thinking, well, what does this random number mean? It's just a random number. And let's actually try that. So we'll take this, we'll get rid of it, and we'll do print Bob's Breads 3. Okay? I'll drag this in, and it prints Turkish. Now, you may be thinking, well, how does it do that? What is the logic behind this? And you're perfectly correct. It's quite interesting logic. So, what actually happens here is, we have 4 elements in the list, and we will name them 1, 2, 3, and 4. Right? And when we're doing print Bob's Breads 3, you may be already thinking, oh, good, that means we're printing the 3rd element, which is rotten. But then you'd think, well, then how come it printed Turkish when we ran it? Because if we go back here and we run it, it prints Turkish even though we entered 3. So why does that happen? It happens because indexing doesn't actually start at 1. So when you try to access the 3rd element in the list, you don't put 3 in. Instead, indexing starts at 0. So it goes 0, 1, 2, 3. And that's why when I printed 3, it printed Turkish. And now you probably will be familiar with starting with 0. You've heard about it somewhere. It's pretty popular among people. But yeah, that's the kind of where it comes from. Because indexing starts at 0, it's just easier for the computer. So keep in mind that when you want to access an element, you use square brackets and the index in the list. Now, and the index will always be the actual place in the list minus 1. So if it's 4th, which is Turkish, you do minus 1 and you get 3 because it starts at 0. So that's indexing. Pretty simple. And so now, if we print Bob's Breads 1, take a guess what it will say. Okay, you probably know it says wholemeal because that's 0 and that's 1. Let's try it out. And ta-da, wholemeal. So that's accessing elements in a list. Now, that's all and good, but what if Bob from Bob's Breads comes in with a new shipment the next day, and that new shipment contains blue bread? And Bob needs to add blue bread to his list. He could create a new list like this, and he could include everything. Oh, whoops. Let me just do this. So he could do all of this. It's the exact same thing, except for he adds blue. But that's not efficient. Another way he could do it is he could just hard code it so that blue comes here, like that. But what if the user wanted to enter something? And we couldn't hard code it like that. We need to add something to the end of the list, but we need a keyword for that. And that keyword is append. So how the syntax works is we go Bob's Breads dot append, and we can enter whatever element we want to append. Now this is where lists get unique, like I said before. In other languages such as Java, when you wanted to append, you could only append the same type. And that is called homogeneity or heterogeneity. And you'll see it right up here. I've just noted it down for the video. So what that means is, if your list is homogeneous, if your data structure, is homogeneous, that means it contains all the same data type, which means we cannot add 1 because it's an integer. However, if we run it, it does work. It does not raise an error. So what's going on? And that's the thing about Python lists. Unlike most other languages, Python lists are both homogeneous and heterogeneous, which means they can contain the same data types or they can contain different data types. So right now, this list is homogeneous. It only contains strings. If we add a 1 to the end though, it automatically becomes heterogeneous. So that's the unique thing about strings. Lists, They're both homogeneous and heterogeneous. Another thing, as you may see below homogeneous and heterogeneous up here, is mutability or immutability. So what that means is, we've actually just gone over it right here. If your list, or if your data structure, I keep saying list, is immutable, that means it cannot be added to. It means you can't add an element to it. The only way is to copy the data structure and paste it and add an element. And even though that kind of works, it's not very efficient. So in this Bob's Breads case, we would not use an immutable data structure. We would use a mutable data structure. And what mutable data structures are, we've already covered it. You can add to them, you can remove to them, you can edit them far more with append and pop and all those kinds of keywords. Now, if we do actually append something, so I'll append another bread, so that was blue bread, right? And I append it, and then we go print, print Bob's Breads. Oh, whoops, Bob's Bread. Okay, and we run it. Oh, whoops. It says white, wholemeal, rotten, Turkish, and blue. Now, you may be thinking, well, look, it appends to the end of the list, but that's not very good, because what if Bob wanted to rank these in order of most, the newest to oldest? Then he would put it at the start. So what we do for that is we go, not append, we actually extend. And what it says is, oh, not extend, sorry. We use insert, sorry. So insert will insert at an index. So if we go insert, and we put an index in. So we've already covered indexes. And because we want to put it at the start, we will put 0. And then it says object. So object is literally just blue bread. Yeah? So now if we run this. Oh, whoops, we forgot to print. Bob's Breads print. And it adds blue to the start. So that's the difference between append and insert. And most of the time you only need to do append. Sometimes you do need to do insert. Now, those are your simple keywords. There are way more keywords. In fact, we can actually see them right here. Go here and we can do Bob's Breads dot. Append, clear is pretty self-explanatory. It removes all items. Copy, it copies the list and creates a new version. It returns a new version. It counts the number, it counts the number of occurrences of a value. So you might be thinking, well, count would just count the number of elements in a list. But we use a different keyword for that, which we'll get to later in the video. So count actually says count the number of occurrences, which means if we do rotten and we do, right? Oh, whoops, because all of these keywords are return elements instead of actually printing, we've always got to print the thing. 1. So what it does is it counts the number of rottens in the list. Pretty self-explanatory. Okay, so now let's see a few more of the a few more methods. So we got append, clear, copy, count, extend. It extends list by appending elements from another list. Index, return first index of value. So what it does is if we entered rotten, it would go 0, 1, 2. It'd return 2 because it's second. Insert, we've already done that. Pop is also another, it kind of replaces, it's kind of replace. And remove first accounts of value. Reverse, yeah, it reverses the list. And sort. Okay, so these are all here, but there's one thing that we really need to look at. It's really useful. So say you want to loop through a list, and you might be thinking, what does that mean? Well, we've already covered loops. So for x in range 10, it would print, it loop 10 times. But what if we wanted to loop through, what if Bob, okay, we'll go over the Bob. What if Bob wanted to, for example, see how many breads he has, or see the names of each bread? We could just print Bob's Breads, but he wants a nice, clean interface. Like, we could just print Bob's Breads, but as you saw before, it prints this as raw input. So what we would do that then is loop through each element and print it. So how would we loop? So we'd go for x or I or whatever iterable you want to use. For x in range len. So len is the return the number of the items in a container, and that container is Bob's Breads. So we'd go Bob's, not do that correct. Bob's Breads, yes. Now, what that's actually doing is it's looping through each bread. So it's looping 1, 2, 3, 4. It will loop 4 times by checking the length of Bob's Breads. And you can also use the len function to see how many elements are in the list. So now let's get this nice UI. So we'll do print bread number, bread number, and we'd put X because X is our iterable. Bread number, for example 1, and then would go plus Bob's Breads, and this is where things get interesting. Bob's Breads, and then we do indexing, and now you're thinking, well, how does that work? We just use X. X is the iterable, which means the first time through it will be 0, which means it'll be white. So that's the good thing about using len. It starts at 0. So now we'll include the X, and that will actually access the index in the list. So because it starts at 0 and it ends at 3, it'll go 0, 1, 2, 3, and we'll do Bob's Breads X. So now, did we forget the season? No. Okay. So now, if we run this, oh, whoops, we need to go int X. It's good to remember that. Okay. Oh, I didn't process that. Oh, whoops, I typed int instead, so we'll go string. Okay. And now if we run this, bread number 0, white. Bread number 1, wholemeal. Bread number 2, bread number 3. So you can see that when it's looping, instead of starting at 1, it starts at 0. Now, it does look okay, but for a baker, bread number 0 kind of looks weird. So we can just go string X plus 1. If we run the, oh, okay. And there we go. Bread number 1, 2, 3, 4. White, wholemeal, rotten, and Turkish. So that wraps up lists, and we want to do one more thing before we go, and that is... Okay, so now that we've done lists and we've explained how to use them and as a data structure, let's actually use them for a problem. So we've got this function here, and we're also calling this function with 2 parameters. So let's actually see what we've got to do. Suppose we have an integer, x, and its array form is its digits from left to right. So if x is 1, 2, 3, 4, its array form would be 1, 2, 3, 4 as a list. Now, it's important to remember that because I'm going to be referring to array form quite a bit in this video. So given x as array form and integer k, return the array form of x plus k. So for example, if we import a as 3, 4, 5, 6 and k as 2, 1, 2, then our output should be 3, 6, 6, 8 as an integer list. So let's get into it. Our first thing to do would be actually to get a and convert it, and then convert it into a string. So all we've got to do is create this temporary string here called string. So we'll call it string integer because I'm going to be doing some things. So we'll be doing for integer in a, for integer in a. So that means we're going to be looping, oh yes, I keep referring to a up here. We're actually going for integer in x it is, yeah, x. For integer in x, we're going to loop through each integer in x, and we're just going to go string equals string plus string of integer. So what it's going to do is convert the integer to a string and then add it to the string. So if we run this now, so we just go print string, and then we go control F5. It's going to print 3, 4, 5, oh, whoops. Let me just get it up again. It's going to print 3, 4, 5, 6 as our string, okay? Now, even though it looks like an integer, that is actually a string. So what we've got to do after this loop is convert it back into an integer. Now what we could do is convert it back into an integer, and then add the integer to k. But to keep it short and simple, we can just do that all in one line. So we can go string equals string int string plus k. Okay, so what this does is, I'll break it down. It does look complex, but it's pretty simple. You take string, which is currently in a string, as you can see right here. Yeah. So what it does is it converts it into an integer, which is what we would have done. And then within that, we add k to it. And then we convert it back into a string. Now, we could have just done, we could have gone rid of the string. So if I do this, we would have literally gotten the same result, except for as a string form. But we want to keep it in string form. You may be asking why, but we're going to do that later. So we're going to show you later why we need to convert it back to a string form. So now that we have it in string form, actually right now I'll explain that why we're doing that. Now that we have it in string form, because we did that, it's easier to append to our output list. Because remember, we got to return the array form, which means we can't just return what we currently have. We need to return it as an array. We can't just return 3668, we got to return 3668. So what we can do here is create our output list. And then we can go for string in string. And then we can go output. So that is our list. Dot append int string. So what we're doing is we're converting back to an int, and then we're turning it into an array. So now we should be able to go return, and don't mind the print. It should work now. If we go return output, yeah, print. Oh, whoops, missing a parentheses there, and then. Oh, whoops. Oh, used the wrong one again. Oh, whoops. It's string plus a. Oh, whoops, k. K is a capital. Did I not do a capital? Oh, yes, whoops. So, one more thing we had to do here. I didn't add the string back in, which is kind of weird, but oh well. There we go. Now if I run this, oh, whoops. Yeah. Now if I run this. Okay, so it returns 3668 as an integer. And if we want to return it as a string array, all we gotta do is get rid of this int. So now that we have this, let's actually go in a bit more depth about how I did this. So what I did first was I made an empty string. Then I appended to the string, and I turned this into a string. And then I converted it back into an int, added k, and then converted it back to a string all in one line. I created an empty list for output, and then I looped through each digit inside string. So string, for example, could after this line, string would become 3668. So we would just loop through each digit and each individual digit. So it'd kind of be like 3 would be the first digit, for example, and then we'd output.append integer, so that would be just 3. So then it would be like append 3, and that's just an easy way to break it down. Then at the very end, it returns the output, and then we print it. So that's just a simple way of doing this. There are other more effective ways, but this is the easiest to explain, and you can squeeze this all into a one-line statement. In fact, there is in Python a default. There's a default keyword called map, which you can use as a way of doing this in a more simple way. So, for example, if I can just get it up from my previous one, if we just comment all of this out, I won't comment it, but you can easily see that this replaces all of this. It is, although, a bit slower, but it's way shorter. So what it does is just it converts string int, and then it dot joins map, and map is the keyword that you can see makes an iterator that iterates. So it's kind of like a mini for loop, and then that's it just does what we literally did, plus all of this, except for instead of these two for loops, it uses the map function, which replaces our for loops. So that's a simple one-line way of doing it, even though it's a little bit slower, sitting at around 352 milliseconds, whether our on the other hand, ours was sitting on 40 milliseconds. So you kind of see that this is fast, even though not the fastest way of doing it. So that wraps it up for this video. It was pretty long. We talked about lists, and we talked about how we can actually use lists in a real-world example. And so we'll see you in the next video, where we're going to discuss dictionaries or tuples. I haven't decided yet. Which are both like kind of alternatives to lists, even though they do different things. So before I explain homogeneity and heterogeneity, and tuples and dictionaries have different properties. So yeah, see you in the next video. Bye!